Hello and welcome to Learning Arduino in Practical, Section 2. I think it's weather go cold and cool, and yes, it's October, and happier Halloween. In this project, we are starting the first project, but for starting, we need to get you some information about electronic components, just a little one, and make a simple flasher with Arduino Uno. In this session, we will talk about some resistors, breadboard, LEDs, and this kind of stuff. LEDs. LEDs or light emitted diode. Each LEDs have two pins. Longer one is positive, and shorter one is negative. There's a tip here that a positive or anode has a little piece of metal inside the LED. So we know as a positive pole as an anode and negative pole as a cathode. If we wanted to look at the LED as a close view, we could show that there is a 2 points of each LEDs. But when we scrutinize LED, we found that there is a positive here and there is a negative here, negative pole here, I mean anode and cathode. So, but it's a semiconductor that is provide light for us, and it's a little very tiny wire that it provide electrical connection between cathode and anode. So let me go to the next. Another component that we really like to introduce it here is breadboard. Breadboard is a kind of stuff that we make our circuit on it, but we could connect our component, electrical component, by wire to each other, and it's really easy to use and really easy to plug and play. It's have some adventures here that we use breadboard because of its simple connection. It doesn't need soldering and easy to use. Changing elements are really easy, and it's appropriate for long time test and learning because we didn't need to making another PCBs and another ones. So each breadboard have two power rails here and here, positive and negative. All of the holes is connect horizontal to each others, but there is a terminal strips that 5 hole in a row here. It's showed here by A, B, C, D, E and F, G, H, I, J. Each 5 holes is connected to each other, and there is no connectivity between them and another holes. Our resistor and their fat family, they are really eat very much. So as you can see here, as each size is bigger, the consumption is increased too. For example, here we have 5-watt resistor that it's really fat ones. It's really absorb current. A resistor is a kind of electronic component that didn't current let path throughout them easily. There's another kind of resistors here, for example, light dependent resistor, LDR, that their resistance is depend on a light that provide here a surface that is in front of the light, and the resistance will be changed. And there's another one is a thermistor. Thermistors are a kind of varistors, sorry, a kind of resistors that their resistance change by temperature, and I saw that they use in air conditioners and this kind of stuff. There's another one here that we know the potentiometers. Potentiometers, we could change their resistance between their pins by turning this bolt, and it's a symbol of resistor in circuit. Arduino Uno, an introduction. Yes, our old friend Arduino Uno, it's a really good one. Here is the two connectors. That it's a USB connector and it's a power jack. If you provide power by USB for your Arduino, you didn't need to install anything in power jack. But if you didn't have any USB, you just need to connect a power jack. But remember that you didn't, when you install a power jack here, you couldn't upload any program on your board. Okay, let me pass throughout our pins. Yes, it's a first pin and easily one, no connection. Another pin is 5 volt, reset input, 3.3 volt, and another one is a 5 volt. There's two ground here, and let me go to the analog port. Analog port is a kind of ports, mine is I/O, input output port, that we could apply them analog signals. For example, analog voltage, sinusoidal voltage, and for example, something that some sensors that they provide analog voltage in their output. Look at the A4 and A5 that they have another rules here that it's I to C interface. Let me go to the digital ports. Here 0 and 1, although they are digital ports, I mean digital pin 0 and 1, they have another duty as a TX and RX that it's for serial interface. Another one, it's digital pins 2, although it's digital pins, it's external interrupt 0. Another one is digital pin 3, PWM, and external interrupt 1. Remember that each pin just allowed it to have one duty, and for example pin 3 didn't have allowed it to have any extra one rules, for example PWM and external interrupt. No, it just could have external interrupt or PWM or input output digital. Let me go to another pins. Yes, here 10 to 13. It's a pin digital I/O. Two of them is PWM, and yes, it's SPI. SPI is another interface that we talk about it completely, and here is another ground and analog reference voltage that we could provide external analog voltage for our board and for our analog inputs. The simplest project in the world, yes, it's Flasher. It's really easy to use, and of course it's have its problems too. In this project, we just connect the LED to our Arduino board and turn it on and off frequently. It's called flashing. It's like this little bulb, it's going to explode itself, but it can, yeah. How to connect LED to our board? At the first, we need some element or component that didn't allow our diode or LED diode that have much current. As we know, LED is a kind of diode, and each diode like to have a really huge amount of current. And if LED have a a really high current, it's burn and it's broke down and it didn't work anymore. So we put a resistor here to limit current that it's through from the LED and protect it from breaks down. I choose 220 ohm resistor here, but there's a point here that because we use Arduino board, there's some inner resistance to each digital ports, and sometimes we couldn't use this element, and there is no problem here. But in this place, and it's just for starting, and our knowledge is basic, so we use this element here. So let me open IDE and have some code here. Okay, it's our IDE. At the first, we need to introduce our global variable. Global variable is something that it's variable that all of the input and output. For example, here I connect my LED positive pole to 13 pin, so I could mention that here as this way: int sorry int LED equal to 13, because I connect my LED to 13 pin of board. I mention here LED as 13. It's provided better situation for my program. And yeah, here I must mention that my pin is output or input. As we know, we connect LED to our Arduino, and it's output because there is output voltage provide to LED and let it on and off. So I write it here, pin mode, parentheses, and there's a semicolon here. It's my way of coding, because sometimes I forget to place semicolon. I place it first, and after that came between the parentheses and write code. So it's LED and it must be output. Okay, it's finished. And here it's a place that our code repeatedly, frequently. So at the first, I need to turn my LED on. So I write here, because I connect my LED to digital ports. 13 is a digital ports. I must mention that digital write, sorry, I wrote it wrong, digital write, yes, it's true, open and close parentheses, LED and high. And I need a delay here, It's delay based on millisecond, so I need about 1 second for it, so 1000 millisecond delay. And after that, and now there, I need to turn LED off, so I must write here digital write LED and low, and I need another delay here. I add this delay here because our eyes couldn't watch something it's really fast. I need delay here to have some specific delay that it provides some situation for our eye to watch LED turn in and off, turn on and off. So let me verify my code. Yes, it asked me to save it. Okay, no problem. And I connect my Arduino board to my computer before, and I upload my program to my Arduino. It's upload done, and I came back to show you how it's happening in action.